Welcome to another Great Cow Basic tutorial. This is part 4 for the PIC18FxQ41 family of chips. We're on section 4. We're going to actually sequence the LEDs on a board, and we're going to set the pace of change using a delay, and that delay is based upon the value of the ADC. So we're using a microchip, a low pink out demo board. It's a PIC18FxxQ41 board. I can show you that here in the lab. Here we go. It's this board here. It's connected up to a programmer. That programmer happens to be a PIC18FxxQ41 today. I think it was a PIC18FxxQ41 previously. I've done some. I just changed it because I can do that. On the right there, on the diagram, you can see a picture of a Curiosity Nano board, and that Curiosity Nano board is hopefully coming to me. Okay. We'll see what happens. Great. So let's look at the layout. This layout is from Chris Roper, and we're going to be looking at making those LEDs rotate. We've seen how we make these LEDs rotate, and we're going to be using a potentiometer. And you can use this layout in here as supplied to wire up your own little demonstration board. So we've looked in the previous tutorials how ADC works, and today we're going to, as I said, use a delay, and that delay can be expressed in microseconds, 10 microseconds, milliseconds, 10 milliseconds, seconds, minutes, or hours, and they're very useful. And Great Cow Basic has a command called wait, and it just needs a time, a unit, and then a time period, and then a unit of time. So you would simply say wait 1 millisecond, but we're not going to have a constant of 1. We're going to use the value coming back from the ADC for that delay. Well, we've seen how Great Cow Basic can initialize the board. We can create variables. We can read the ADC. But we're going to read the ADC into a bigger number called a word, and that word can actually hold the bigger range, because we're going to use read ADC 12, and read ADC 12 returns a value of 0 to 4095, which essentially means if we use milliseconds, we have a range of 0 milliseconds to 4095 milliseconds, a 4-second delay, which is pretty slow, and we're going to play with that a little bit. Then, as I said, we're going to wait for that period, and then we're going to rotate around. And here is how we've inserted the wait in this program that we've seen previously. So I've inserted the wait for a delay, and we're just going to read that ADC, wait for a delay, and then rotate the LEDs around as previously we have. So with no more ado, let's have a look at some code. Well, we've seen the editor before. The code that is in green is commentary. The code that's in blue, you can see, has a little bit more, is more prominent and is not a comment. So, what have we got to do? We do the standard setup that we do before. We specify a chip, a hash chip, a 18FxxQ41, and I use it option explicit, and this means I have to determine and define my variable types. I have some constants to define the port of the LEDs. It's on port LAT-C, and on and these are just constants to say that those particular LEDs are digital outs, and we need that. And then I define a constant for the potentiometer, just so I know where it's connected. And I just say that the direction is in. So we saw this before. We set up some other constants just to set the initial state of the LED, and away we go into the actual program itself. So here's the big do loop. We saw that in the, I'll just indent that, and you can see that there's a do loop here, which is in the flow diagram, the do it forever. And we're going to read the ADC value using the read AD12 command on that particular port AN0, and we're going to put that into a variable called ADC. And if we look slightly above, we can see it's a word, and we need a word because the range of a byte is 0 to 255, and a word is a lot bigger, and we can hold the range that we need to in that word. Then we wait for the ADC value, in terms of milliseconds. So whatever we get back from ADC, we are going to wait for it. And do you know what? It's as simple as that. And we should just program it up and see what happens, yeah? It's flashed on the programmer. And we've now got one LED that's a light. And it's just changed in the LED. Now I've changed the voltage on the programmer here to make it a little bit easier for us, okay? It was a bit too flashy for me. So I'm going to rotate this pot, and as I rotate the pot, you will see that the LEDs move faster. Let me get out of the way. There we go. Look at that. So I'm rotating the pot, and sure, as I rotate the pot, the LEDs change value. Now, the trick here is the range. The range here is quite large. 4,000 milliseconds is a lot of milliseconds, and you know it's just not it doesn't seem that positive in terms of the way that the range works. Okay, so I'm just going to take us back to the PowerPoint, and we're just going to look at PowerPoint for a few seconds just to see that we can change this code to make it more responsive to our needs. So I'm going to use a command called scale, and I'm going to transform the existing value of the ADC, the range, into a new value with a specified scale. And I'm just going to insert that in our code here. I'm just going to insert a command, and I'm going to scale the ADC to a specific value, and it will make the rotation of the LEDs more responsive. Scale is very useful in your own programs. So let's have a look at how we're going to do that. I'm going to very quickly insert a command here. So I'm going to say my ADC value, I want to scale that. So I'm going to type the word scale in, and we're going to introduce a few things whilst we're in here. Notice it's gone blue in the IDE. If I press F1, it will take me into the help, and the help is now on my desktop. So let me have a look at my desktop for you, and the help has come up. So in the background, it's I can just close that down one moment. I'll press F1 again, highlight the word, press F1, and here is the help. The help is on the web, and there's detailed help throughout Great Cow BASIC. So what I need to do is I need to give it the original value of ADC, and that comes with a range of 0 to 4095. We know that. And I'm going to say to it, I want to limit the range between 2 milliseconds and 100 milliseconds. Let's say 50 milliseconds, okay? And what it will now do is transform ADC into a range of between 2 milliseconds and 50 milliseconds. And then it will do the same weight as before. So let's bring that up, and let's just program that and see what happens. There we go. Good. Oh, look at that. That's a bit more responsive. So that's my fully rotated. And now, oh, look at that. That is a bit more exciting. Okay. Now, these delays are all a function of the frequency. So what do I mean by that? If I change the frequency of the processor, microcontroller, the delay still works. So let's just change this value here to maybe 100 milliseconds, and we'll just reprogram it. And then what we're going to do finally today is change the frequency of the chip just to see there's no difference. Okay, so now my delay is a bit slower, and as I rotate full on, I'm getting a delay there, which is quite meaningful. Now, you can play with this to your heart's content. Now, you can see that they're changing every 100 milliseconds. Now, let me just change the frequency of the chip here, and you will see that the LEDs do not change. So I'm going to set it to 1, which is the frequency of 1 megahertz. What did I say? Kilohertz. And it's programmed it, and we'll get the same rate of change. If I set that to 8, Great Cow BASIC handles the internals to ensure that the operations of time is valid. We'll be looking more and more into time and timers as we go through the training and the tutorials. So what I wanted to look at today is reading ADCs and weights. So let's have a look back into PowerPoint to summarize up where we are. So we wanted to do that scale. I've added that scale into there, and so I think we've done it for today. We've looked at sequencing the LEDs using a delay from the value of an ADC. Next tutorial is using an input to set the LED. So we're expanding out the capabilities of this program as we move forward. So another tutorial for Great Cow BASIC for the 18FQ series. Thank you. Enjoy.